If you ask Codex to review code and it answers, overall the implementation looks clean, you did not get a code review. You got a polite summary. A real reviewer is not there to admire the code. A real reviewer is there to find the bug you might ship. The goal is not to make Codex sound smart. The goal is to make it inspect the change like a careful teammate: what changed, what can break, how serious it is, and what the smallest safe fix looks like. So in this video, we will turn Codex from a vague reviewer into a useful one. The first rule is simple: review the diff before changing anything. When Codex starts reviewing, do not let it immediately edit files. A code review is a read-only pass first. Ask it to inspect the change set with git status and git diff. If the folder is not a Git repository, make it say that clearly and use file inspection instead. The first review question is not, how do we improve this code? The first question is, what is inside the change set? Which files were added? Which files were modified? Which changes are directly related to the task? And is there any unrelated work that should stay out of scope? This matters because AI reviewers often drift. If the diff boundary is unclear, Codex may comment on old code, rewrite a nearby component, or turn a focused review into a general refactor suggestion. A good review starts by protecting scope. The second rule is to ban vague praise. Looks good overall is not a finding. Consider improving robustness is not a finding. Maybe add tests is not a finding unless it explains which behavior is untested and why it matters. Make Codex report findings by severity. Use P0 for crashes, security problems, data loss, payment issues, or anything that can seriously harm users or the business. Use P1 for important user flows that break under realistic conditions. Use P2 for edge cases, maintainability risks, and test gaps that should be addressed but are not immediate blockers. Severity forces the reviewer to make a judgment. It also keeps the final answer useful. A P1 bug should not be buried under 6 style comments. Every finding should include 5 fields. First, the file path. Second, the line number or function name. Third, the trigger condition. Fourth, why this is a real problem. Fifth, the smallest fix that addresses it. This format changes the review. Instead of handle errors better, Codex has to say, when the update request fails, the submit button stays disabled because the catch block never resets submitting. That is reviewable. That is actionable. And if Codex finds no issue, do not let it write a compliment. Make it say no issue found, and list what it actually checked. Now, what should Codex look for? A practical review can focus on 5 risk categories. The first category is data flow. Where does the input come from? How is state updated? Can cached data become stale? Can pagination, filters, dates, money, quantities, or permissions be calculated incorrectly? Many real bugs hide in data flow because the happy path still looks fine. The second category is failure paths. What happens when an API fails? What happens when the list is empty? What happens when the user has no permission, the file is missing, the network times out, or the operation is cancelled? AI-generated code is often strongest on the happy path and weakest where the system fails. A serious reviewer should look directly at those failures. The third category is user experience. Does the button disable while submitting? Is there loading feedback? Can the user retry after an error? Does the error message explain what happened? Does mobile text overflow? Does closing a modal reset the right state? These are not always catastrophic bugs, but they are the difference between a demo and a product someone can use. The fourth category is test and verification gaps. Not every project has a full test suite. That is fine. But if a change touches authentication, billing, permissions, data transformation, or a core workflow, Codex should say what verification exists and what is still missing. No tests found is a valid review note. Pretending tests passed when no test exists is not. The fifth category is security and privacy. Look for credentials, tokens, cookies, PI keys, verification codes, private URLs, customer data, and debug logs that should not appear. For tutorials and media work, this also includes terminal screenshots, browser address bars, exported documents, sample logs, and video frames. Sensitive data can leak outside the code. Now compare a weak review with a real one. A weak review says, the form logic is clear. Consider adding an error message. A real review says, P1, after save fails, the submit button stays disabled. File, src/pages/profileform.tsx. Function, handle submit. Trigger, update profile throws inside the catch path. Impact, the user cannot retry without reloading the page. Minimal fix, move set submitting false into a finally block and keep the error message. That is the level of specificity you want. It tells you where the problem is, how to reproduce it, why it matters, and how to fix it without refactoring the whole form. The fourth rule is workflow: report first, fix later. Do not let Codex review and modify in the same pass. Ask it to produce findings first. Then a human decides which findings are real, which are style preferences, and which are false positives. Only after that should Codex fix confirmed issues. This keeps the agent from turning every suggestion into a code change. It also makes the collaboration easier to review. Codex finds risks. You choose priorities. Codex applies the agreed fixes. Then it runs the relevant checks. If you use superpowers or a similar workflow system, you can make this even more formal. Use an independent reviewer context after implementation. Give the reviewer the original goal, the acceptance criteria, and the diff range. That separation matters because the implementer and the reviewer should not be the same mindset. But you do not need a special tool to start. A strong prompt is enough for small changes. Here is the prompt pattern. Do not modify code yet. Perform a code review only. First inspect the change set with git status and git diff. If this is not a Git repository, say so and use file inspection instead. Review only files related to the requested task. Do not comment on unrelated code. Look for real risks, not generic praise. Prioritize data flow, failure paths, user experience, test gaps, and security or privacy issues. For each finding, use P0, P1, or P2. Include file path, line number or function name, trigger condition, impact, and the smallest fix. If no issue is found, say no issue found and list what you actually checked. Do not apply fixes until I confirm which findings to address. Use this whenever the result matters. Use it before merging a feature. Use it after an AI agent writes a large change. Use it before shipping code that touches auth, billing, permissions, user data, external APIs, or generated artifacts. The point is not to make Codex more critical for its own sake. The point is to make the review useful. A useful review does not flatter the implementation. It names the risk, proves the trigger, ranks the severity, and proposes the smallest safe fix. That is how you make Codex review code like a real reviewer.